They're popping up everywhere. When most of us think about satellites, this is what we think of. And if you really look, millions of homes all around the country have satellite dishes. But the real story of satellites isn't down here. In fact, it's thousands of kilometres away, up there. Way above the Earth's atmosphere, satellites do much more than sending TV into our homes. Satellites are part of an international communications system that sends telephone messages, TV pictures and computer data to every point on the globe. And they also take pictures. Looking down from space, satellites can zoom in to gather information we couldn't collect in any other way. This is Britain's biggest satellite picture library. The pictures are stored on thousands of reels of magnetic tape. To view the pictures, you need a computer, but then to make sense of the huge amount of information they contain, you also need an expert. Claire Power is one of those experts. This picture shows fields and the coast of Essex, but the colours tell her much more than an ordinary photograph.
This image on the screen here, it's not actually taken by a camera, it's taken by sensors which are on the satellite. And these sensors can actually take a lot more information out of the ground than a normal camera. This means that all the fields are all different colours. These are not the colours you'd expect agricultural crops to be in. So we have to use computers to process it and simplify it so that our eyes can understand it. The problem is we actually want to know what is in those fields, and this is where Andrew comes in.
Andrew St Joseph studies birds.
Right.
But today he's calling farmers in his area.
What I'm trying to do, because I've got in front of me a satellite photograph of the whole of this parish, is to find out which colour of which field equals which crop. Now, looking at your lowest field, C field, that's winter wheat.
Andrew needs to know what all the land around the birds is used for. Once he's found out what's in a few fields, Claire's computer can do the rest.
We asked Andrew St Joseph what was actually in this red field here. And he came back and he said this is winter wheat. So we could actually then begin to pick the areas of winter wheat throughout the whole image. So with this, we can actually provide people with much more detailed information and much more useful information than you can actually see with your eyes. Now, this pink area here is actually salt marsh. This is the area that Andrew's really interested in because this is where his birds do their nesting and feeding.
But the salt marsh is under threat, and so these birds are too. The sea is washing the salt marsh away, and if nothing's done to stop that, soon there will be nowhere left for the birds to live. But protecting their habitat will need cooperation from everyone who uses the land around here, like farmers with fields along the coast. So where are we now, Andrew?
We're on the coast and we're looking out over the salt marsh that the birds are finding so useful. In summer, most of them are way up on the Arctic tundras of Russia and Norway, where they breed because it's so remote there. They come down here in winter, and they come here for two reasons. Firstly, the wonderful food supply on the mudflats, and secondly, the security of these estuaries.
What do they eat?
Well, you've got two sorts of birds out there. You've got the geese, who are vegetarians. The other birds are the small waders. Now, they're not vegetarian at all, they're carnivorous. And they feed on all the lovely worms on the mudflats, which, surprise, surprise, are highly nutritious and probably very tasty, if anyone knew. It's a very important ecosystem. The problem is that it's eroding away faster than ever before.
This barrier was built to protect the land, to stop the sea from washing away the coastline, eroding the salt marsh and soft mud. Yuck. Protecting the birds means building the right barriers in the right... But surveying the land to do that will be a huge job at ground level, because the coastline here stretches over 250 kilometres. Even this high you can't see that far. Andrew needed satellite pictures. Pictures from space. Wow, what a great view. So what would you have done without the satellite?
Panicked, I think. That sort of data would not have been available at all.
And that's the real power of satellite pictures. They bring us information, data, which will be very difficult to gather on the ground. But satellites once seemed a real threat. In 1957, the then Soviet Union launched the first satellite from a world of suspicion and fear. In those days, America and the Soviet Union were enemies. Spies were everywhere, and space was a good place to spy from.
Until 2 days ago, that sound had never been heard on this earth. Suddenly, it has become as much a part of 20th century life as the whir of your vacuum cleaner. It's a report from man's farthest frontier, the radio signal transmitted by the Soviet Sputnik, the first man-made satellite as it passed over New York earlier today.
Do you admire the Russians for doing it or not?
No, definitely not. I said we should have been the first ones to have it, if there's such thing.
We fear this. We fear that they have something out that majority of the people don't know about.
More than 30 years on, most of us have never even seen a satellite. Yet today, more are being launched than ever before. So just who's making these mysterious spacecraft?
Hi, I'm Jeff, and we're building a satellite. Would you like to come take a look?
This is what every satellite builder is wearing these days. An all-in-one cotton jumpsuit with matching gloves and accessories. Not very fashionable, but very functional. Jeff needs to keep very clean.
This is the clean room where it all happens. We have 3 weeks to put the satellite together and ship it down to South America for the launch. But today it's all in pieces, and we have to take these pieces, put them together, and build the satellite.
This satellite is being made for the country Korea. A team of Korean engineers have come over to Britain to build it. They've called the satellite KitSat. It's made up from layers of electronics, like radios and computers. KitSat will need them to send and receive information once it's in space. This is the last chance there'll be things okay inside.
Well, once we've launched the satellite, we have no way to ever get it back or to touch it again. So every little piece of dust and every mistake that we make can be the one that causes it to not work. One of the things the KitSat's going to do is take pictures of the Earth. This is the bottom of the satellite, and in the bottom of the satellite is a special printed circuit board with a camera on it that'll look directly down at us on the Earth. If you want to find out how it really works, you got to talk to Mark, because he's the guy that designed it.
Right. This is the sort of image we will hope to be getting from KitSat. It's looking down through the bottom of the spacecraft, and we can see the 2 antennas in the image there. And directly below the satellite, when this picture was taken, was the English Channel, a bit of France, Belgium, Holland, and the south of England. Just like your camera at home, there's a lens which projects the picture beneath the satellite onto the sensor inside the camera, which captures the light. And this is what the sensor looks like.
Inside here, there's no film. The sensor is electronic. It's covered in thousands of tiny light-sensitive cells. Each one records the brightness of the light it sees, and this is converted into a number. The numbers, digits, are then sent back to Earth as a stream of digital information, which can then be converted back into a picture again.
Before we launch it, though, we have to test it to make sure that it's working properly. And here's a picture we took earlier out of the clean room window. You can see the window frame here, and behind it is Guildford, and we can see a number of buildings and some trees. One of the advantages and one of the new things we'll be doing on KitSat is flying 2 cameras. One that produces this type large-scale image, but also one that has a zoom to give us close-ups And after we've zoomed in, this is what the satellite saw. There's a lot more detail in this picture, houses, trees, and cars. But there was a problem. So if we go back to the other camera for a second, when we looked at the pictures, we saw a number of spots on the picture that we couldn't explain. It turned out that these were caused by tiny bits of dust which had settled onto the lens. I guess the clean room wasn't as clean as we thought.
This calls for the bat classes.
It seems crazy, but a few specks of dust in the wrong place could ruin the satellite, so they've got to get them out. Finally, everything's ready, and the satellite can be packed up to begin its long journey into space. Next stop is South America. There it will be launched on a rocket, taking it far above the Earth. But how will it stay up there? What will stop it just falling back down again? To answer that, we have to go back in time.
Traverse! Master Brooks, more shot for the magazine!
300 years before the space age, that cannon was high-tech. But what's one of these got to do with a satellite? Well, there's a clue in the instruction book that came with the cannon. Thank you. And here's how to hit your target. Not easy, because cannonballs don't fly in straight lines. They go in curves. That's because they're heavy. Gravity pulls them down towards the Earth, so eventually they hit the ground. Okay, so what happens if the cannonball fires faster? By using more gunpowder, say. Here's the curve the first ball followed. But if the ball travels faster...
Fire!
The curve stretches out further before the ball hits the ground. Handy to know that if you're going to storm a castle. But if you want to go into space, there's another curve to remember. The surface of the Earth. But what would happen if you could travel so fast that the curve of your path stretched out to match the curve of the Earth? Well, then you'd go into orbit. Gravity would still keep curving your path downwards, but the ground would also curve away by exactly the same amount. In orbit, you keep falling forever, but the curve of your path means you never come back down to Earth. Many people have helped to build the satellite KitSat. It's now waiting to be sent into orbit on board this rocket. But to launch a rocket, the weather must be just right. So I went to find out what the weather forecast was and how satellites already up in space can help weather forecasters like Suzanne Charlton. Hi, Suzanne.
Hi, Helen.
Nice to see you.
Sit down.
Thank you. Now, there's a satellite being launched from French Guiana tonight. What's the weather going to be like for them?
Looks like it'll be fine. Good weather window for the launch.
Excellent. How do we know?
Well, it's not all that straightforward. I don't just make my mind up it's going to be fine, obviously. First of all, we know what the weather's like around the globe now. And we also understand the science of how the air is going to be moving around and developing, so we can predict what's going to happen in the future. If we take a look at the globe, Most of the heat coming in from the sun comes down because of the tilt of the Earth around the equator here, and the poles are much colder. So we see that the Earth tries to move the warm air polewards, but of course that's complicated again by the fact that the Earth's turning, to get vortexes and spinning areas of air moving around the globe. Those are the weather systems that we know.
Now that, where on earth do you start with a forecast?
Well, first of all, we have to know exactly what's happening now. We have thousands of observers around the world, but the satellites look down through the depth of the atmosphere too to tell us what's happening, not just... It's an awful lot of information, yes, and my job really is to help put it into everyday language. And that's another place that satellites really come into their own, because they're such a graphic demonstration of what's happening.
Now this is where the satellite's going to be launching from, is that right?
It's just in there, yes. Here's a slightly different picture closer in. And you can see that there are areas of heavy showers. They're moving away now, and this clear slot looks like it's going to come over just in time for the launch.
Now, how do you actually turn that into a weather forecast on the television?
Well, do you want to have a go?
I'd love to.
OK, let's have a go. Helen, here we are, the all-important
studio
button. The real technological breakthrough is to look straight towards the camera. You'll be able to see the picture of you with the chart behind.
Gosh, yes, hello.
But I'm going to be really cruel to you now. The news is just overrun by 15 seconds, and you've only got 15 to tell us about the weather in Kourou, starting from now.
Good evening, and the weather for Kourou in French Guiana for the satellite this evening. As you can see, there's plenty of rain about with the odd thunderstorm, but this is being pushed westwards by the wind coming in from the east here. You see some brighter patches coming up, 8 miles an hour wind, just pushing all the wind, and I'm finished.
Well, I thought you did really well.
Suzanne's forecast was spot on, and in South America, the launch was only hours away.
When it gets launched, that's the most dangerous and damaging time in the life of the satellite. The rocket is vibrating a lot. There's pieces of dust can be shaken loose, pieces of the satellite can break, and after that we have no opportunity to fix it. So it'll be after launch, when we first try to turn and then try to get a picture from the camera, that'll really tell whether we've been successful or not. Between now and then, there's only a few checks that we can do.
Kitsat's being made ready for launch, but it won't be alone on top of the rocket. There's another small satellite which will be sent into space at the same time. But they're both just passengers, hitching a ride with a much bigger satellite, 3 on their way to orbit. In Kourou, it's all systems go. Back in Britain, it's nearly midnight. Not everyone from the Kitsat team can be at the launch site, so the others are rigging up a dish to watch it on TV. The pictures will be sent live by satellite.
Injected cow. Currently, consumers have no way to identify products that...
Everyone who's helped build Kitsat is here.
We now go live to the Space Center in Kourou, French Guiana.
À tous de l'EDO, attention pour décompte final.
The countdown has begun.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Décollage. Les pressions foyer sont normales.
So far, so good. But suddenly, they lose the pictures. Desperate to find out what's going on, they manage to get through to launch control. Now, all they can do is wait.
Third stage. Third stage is okay? That's good, because that's usually the one that worries us. Yeah. So that has gone okay? Okay.
The rocket's already several hundred kilometres above the Earth. In less than a minute, They'll find out if Kitsat's made it into orbit.
Okay, thank you. Okay, it's in orbit.
In Korea, the launch has hit the headlines. It's the country's first satellite. But that's not the end of the story. Kitsat may be in space, but does it work?
A lot of things can go wrong in a satellite. There are thousands of parts, more than thousands, and if any one of them doesn't work, if it's the wrong one, you can end up with no spacecraft at all.
These radio aerials are the only link they have to communicate with the satellite now. For the team in the control room, this is a very tense moment.
We send some commands to turn the spacecraft on, and it's a long sequence of commands. It's not something where you just type a key and the thing comes on. And so it's 20 or 30 seconds, and everybody's wondering, the satellite's coming up, is it ever going to transmit?
They're listening for a change in the sound from their radio receiver, which will tell them the satellite's working, that it's live.
I heard this burst of transmission from the spacecraft, and again, I jumped up and was raving about it, and people hadn't picked up on exactly what happened. But then as soon as they heard it, there was a huge explosion of laughter and clapping. To see the final picture come out really was a moment of great gratification for everybody, and we knew that we had a live one, and that was really, as far as I was concerned, that wrapped it up, because I knew that everything that I was really worried about was working.
At last, it's time to celebrate. Kitsat is up and running. It's joined thousands of others already in space. Soon there'll be more pictures from the newest eye in the sky